Great. Thanks, everybody. I appreciate you attending today. As you know, with the liquid cooling paper that I recently sent out, I vowed that I was going to um, interview movers and shakers in the industry. And so today, I would love to introduce to you Liz Cruz, the Chief Marketing Officer from Accelsius. Liz, thank you for joining me today.
Of course, I'm excited to chat with you.
Yeah, likewise. So, Liz, why don't we start? Why don't you give everybody listening a little bit of history of what you're doing at Excelsius and your history in the industry?
Sure, absolutely. So I started in the industry back in 2010 as an analyst for what was at the time the firm was IMS Research. It's been under many brands, most recently Omdia. And I did technology forecasts for various sectors of the data center industry, looking at liquid cooling. I did the first liquid cooling forecast back in 2015, obviously a different situation back then. And I spent a couple years doing content programming for some of the big data center events and media publications. And then I came to Accelsius almost exactly 2 years ago, which is, as we'll talk about today, a really exciting technology. It's two-phase, direct-to-chip liquid cooling technology. Your paper does a good job providing some information on that, but I'm sure we'll get into it more today.
Yeah, thanks for that. It is exciting. There's so much going on in the industry right now. Liquid cooling is at the forefront. I mean, it's no mystery. This is all completely self-serving, right? PTS, for those who don't know or remember, PTS Data Center Solutions is the company that I formed 26 years ago. And really, it's got three divisions. And the one that is up on the screen that you're looking at, sorry, there, INTUVA. INTUVA Solutions is basically the company that designs and builds data centers. And so we're doing it today, Liz, so that you know my largest customer segment is the federal government. And then underneath that are data center operators. And then we're doing that for co-location and as a service players. And then our long legacy of commercial and industrial people like Pfizer. So we support Pfizer, even though they're out of the data center ownership for a long time, we support 1,100 sites globally. And so it's interesting times, like the Chinese say. They say, may you live in interesting times. And although some days I've had my fill of interesting times, I take a little nap, eat a little pizza, it goes away, and I realize, we probably don't want to be alive at any other time in history because it's very exciting right now. So I sent you a bunch of questions. I wanted John to jump right into them. Liquid cooling has been described as a real game changer in our industry for AI and specifically HPC workloads, high performance computing. From your perspective, what are the primary forces that are driving its adoption over the traditional ways of cooling?
Yeah, absolutely. It's really the GPUs and the fact that they just got too hot. I mean, we've been talking about liquid cooling. Like I said, I pretty sure it was 2015. I did the first report. Cool IT's been around for 20 years. Liquid cooling has been around for a long time, but not at all widely adopted. And the only reason now that it is because it's required. Companies cannot do these AI workloads, and you need to be investing in AI to be competitive in the future. It's really just because they have to at this point is why.
Yeah, I'm on record of having saying that as sophisticated as our data center industry, AI caught the data center completely off guard, right?
Yes. Yes.
Remember, just not too long ago, we were all yelling, "Oh, keep water out of the data center. Water, data center, bad." Now we can't do it any other way. We've got AI workloads that are confounding the power for data centers, right? These
Hmm.
large language models, from switching gears to talking about power, they're overwhelming facilities because of the way large language use IT in bursts of power. And
Yes.
as an engineer that designs them, I have no choice but to either build a very sophisticated way to track the load, very difficult to do, or just oversize everything for what that peak load is going to be, which makes the cooling even more complicated. So, how does the shift in liquid cooling compare to past technologies that you've seen and been used as the data center transitions? And where do you think? What do you think? What's your target market that you're looking for, or what should I should say? How is on-premise versus cloud computing adapting to the Excelsius way of using liquid cooling?
Yeah, good question. So, in terms of how it compares to past technology adoption, I know in your email you had mentioned cloud computing is probably the last big, sweeping change that the data center industry faced. And that was very much more a business or operational shift and
Right,
driver. It was to move CapEx to OpEx, and it was to move non-expertise data center management to operators that had that expertise where that was their business, right? So it was
right.
very much a operational choice versus I do feel like liquid cooling, I mean, when we introduced Accelsius and when I talked about liquid cooling a decade ago, it was very much about the sustainability angle, which is obviously so important. And so we talk about that. And when it's a sustainability decision, again, that's a choice, versus what it has come to now, where these chips require liquid cooling. So it is a technology necessity that is driving it, which is making it a much faster shift and almost a binary decision that is what's driving this crazy uptick we're seeing.
Right. So, we're going to talk about, I definitely want to dig into the way Excelsius is doing it because you're kind of a cut up differently than the way everybody else is doing it in the two phase. And I want the listeners to understand that. But I want to talk about the market before and some of the trends that are going on. And so, with that being said, the AI, we said the AI is pushing data centers to their limits. So before we talk about the technology, what do you see as some of the trends that are going to shape the future of cooling technologies? Like, what is it? Before we even get to what Excelsius is doing now, where are you taking it?
Yeah, so I think what's really going to drive future cooling technologies is where the money is ending up. So
Right.
there's so much money in every which way supporting AI. I mean, even, investment in utility is now a good opportunity because it's benefiting from AI. Everything around AI is affecting the economy. I mean, uh, was it CoreWeave that used their GPUs as collateral? I mean, so there's a lot of money in AI in these data centers and specifically in the GPUs themselves. So I think what's going to drive the cooling decisions of the future are protecting that investment. This is a tremendous financial investment. And so what can we do to ensure that that is protected? And what I'm also hearing increasingly so is it's not just a financial investment that we need to protect, but it's also if something happens to it, it's almost impossible to replace it. So if there's damage or something occurs where a GPU needs replacement, I mean, the supply
Yeah,
chain backlog for NVIDIA, you're not going to get it.
yeah,
So I think that's really what's going to drive cooling. Again, it's not going to be a nice to have. It'll be,
a
companies that are
necessity.
backing this require some level of assurance.
I like telling people all the time that if AI was a clock, a 24-hour clock, much like the clock behind you, right? If it was a
Giant.
24-hour clock, we're only at 2 o'clock in the morning, right? It feels like AI has been around forever. Hell, my engineering thesis was on AI, and that was 426 years ago when I was back,
Roughly.
right? No, but seriously, it's the oldest new technology that has been around. The difference is where we find ourselves. We've got 22 hours left to go in the evolution of AI. By noon, we're not even going to recognize the world, right? It's going to
Yeah.
be a different world. So, Gartner predicts that 60% of new data centers will house AI and HPC workloads. So, how do you see cooling strategies evolving to keep up with this? And before I let you answer that, do you think that what's driving the adoption of cooling technologies or liquid cooling technologies right now is around large language models? Do you see the idea of the large language model, being the sole thing that drives it, or do you see other things like small language models, inferencing, other things that are going to reshape the cooling landscape that we're going to drive that 60% new data center adoption of handling AI and HPC workloads?
Yeah. So on the first part, the 60% adoption, or 60% of data centers being AI data centers, I think that's driving two things. One, in greenfield builds, they're all being built with facility water to the rack so that
Yep.
you do either so that you can do direct to chip. And yes, there's various ways of doing liquid cooling and direct to chip, but I think that the greenfields we're seeing are being built to support liquid cooling. In the brownfield data centers, what we're starting to see is where AI is being moved in or being implemented or deployed, they're having to come up with a band-aid solution. And so
Yeah.
in those cases, we're seeing a lot more liquid to air CDUs than we would have expected, or a need for liquid to air CDUs, because they can't completely redesign and bring in facility water. So they're looking at liquid to air for the AI deployments. Also, in those situations, we're seeing a lot of hybrid. We're seeing
Yeah.
cooling next to air cooling,
Yeah.
which it should be enabled. That should be something that we can support as liquid cooling vendors, because that's the reality. It's going to be some hybrid spaces. On the the large language models, that is the majority of the business we see. And when I talk to analysts, same thing. Inference, my understanding and the expectations is that, when you said at noon on the clock, it's going to be the majority will be inference, and that's where ideally companies start making money from AI.
Yeah.
But right now, it's very much
Yeah,
LLM.
large language models are. And before we get down to the technologies, yeah. So we've talked about that performance is one of the things, sure, GPU performance is driving it. Um, Energy efficiency and sustainability are two drivers. Are there any other things, liquid cooling technologies that align with the broader environmental goals that you think that you guys are bringing to the forefront here? With other than just performance, sustainability, and energy efficiency. Is there anything else I'm missing?
In terms of what liquid cooling can kind of do for the
Yeah,
market.
like what, broader, like for what are the broader environmental? I've always seen broader the environmental impact more of my European customers than they do in the United States. But do
Totally.
you see the environmental impact of liquid cooling technologies being a driver, or is it purely just performance and the performance, the need for the cooling at the rack?
It's so funny. I do think that it is in the US right now, it's performance. I spoke with one of the largest builders of data centers for an hour one day, and he was talking about exclusively performance driving his interest in liquid cooling. And then at the end, I was like, well, what about your European data centers? And he's like, oh, yeah, that's only energy efficiency. It was like a completely different conversation.
Completely different talk track.
And that's what we're seeing in actuality too. I mean, that's definitely where a lot of our customers are.
Yeah. And you made the distinction between the greenfield and the brownfield. We're seeing the same thing. All greenfield builders want to build out to meet that new demand, right? I was recently talking with Paul Perez, a fellow at Dell. He used to be data center architecture. Now he's part of the Fed group, but he was saying Dell was delivering 200 kilowatt rack densities now, with soon to be 500 kilowatt rack densities. That's just getting, astronomically large things. What we like to say in the brownfield, though, we see a time when the smaller operators, especially, that were not prepared from either a power or a cooling standpoint to meet the demands of these AI and HPC workloads, their facilities are going to be challenged because of the things that we
Mhm.
talked about. They don't have enough water. They don't have enough capacity in their chilled water loops. So they have to increase capacity by unit of power because the space is shrinking, but the densities are increasing. And
Mhm.
also, the amount that they're going to be able to deliver to a customer is going to be challenging too, because again, of the way a GPU uses bursts of load, right, as opposed to a steady stream of power that's more traditional of an IT stack, or at least a 10% swing, right? The 10% swing wasn't so bad, big swings that are going to cause problems. Let's get into the technology of Accelsius. Could you break down the differences between what you guys are doing at the direct-to-chip cooling and the other technologies that are out there, rear door heat exchangers and full immersion? And give me your take on how you guys differentiate yourselves and why you're building a better mousetrap, if you will.
Of course, yeah. So, in my mind, I really think of it in terms of four categories: immersion, single phase, two phase, and direct to chip, single phase, two phase. Rear door heat exchangers, I kind of think a little bit on the outside, because it still relies on air to push it,
Right.
through to the liquid cooling on the back of the rack, basically.
Yep.
And it's limited. I mean, we've seen, rear door heat exchanger companies advertise as high as like 70 kilowatts, but in actuality, I've never seen that or heard that. It seems like it's capped, taps out more like around 25 is the average, versus immersion and direct to chip, which you can be in the hundreds of kilowatts per rack. So immersion is where, it's a tank where you are dipping your
Yep.
servers into liquid, either single phase or two phase, non-conductive.
Yep.
Um, and we kind of, when we started 2 years ago, some of the people we were talking to were evaluating immersion as they were evaluating us. That is not the case anymore. In your white paper, you have the Gartner hype cycle, which is great. And I mean, immersion, it's in the trough of disillusionment, which is great for Accelsius. I do think it has use cases in humid environments.
We're almost exclusively in the crypto mining space right now. If you're
Yes,
going to do an ASIC, that's still my go-to right now. So I tend to agree with you. Everybody in the IT industry that ever has to pull a board out
yes.
realizes that drip dry in any IT in form of that. So yeah, I agree with you 100%. And
That's
so
funny. I hadn't
yeah,
heard the drip dry. I like that. So yeah, so really what people are evaluating in the IT sector is single phase versus two phase. Two phase is the new, kind of the new kid on the block. We look like and we work like single phase for the most part. With single phase, a liquid flows into the cold plate and it heats up and goes out.
right.
And you can only heat up the fluid PG25 so much before it cannot remove any more heat from the chip. And so it flows out. The only way to remove more heat is to flow water faster.
Yep.
To lower the temperature at the facility, lower the inlet facility water temperature, versus two phase, which we have a non-conductive dielectric, and we use Honeywell's 1233 ZDE, so it's widely commercially available around the globe. So it's something that's in traditional HVAC. Goes into the cold plate, nucleates or boils, and then comes out as a vapor. And so what that does is I mean, I'm sure you understand with your engineering background, but uses the latent heat.
Yep.
That phase change can remove a lot more heat than single phase alone can. So we're able to remove a lot more heat. It also enables a more uniform removal of the heat. So versus where you're flowing it over, there's going to be different hot spots on there. The vaporization means that it's uniform overall, which is really important for GPUs in terms of the different junction temperatures and making sure that it performs as well as it can. So that's really, it's the fluid itself. Ours, because we are then needing to condense the vapor back into the fluid, our system is sold comprehensively. Like, we can't, you can't buy the manifolds from one company and the cold plates from another. We sell a complete system. And so that's really where ours differs. And I'll say that, yes, the performance far exceeds what single phase can do, but it's also the fact that it's non-conductive. And to your audience, it's the federal, industry, or it's the insurance verticals that really care about really not having water in the data center. PG25 is conductive. When it
Yep.
leaks, it does destroy the server. Versus a dielectric is non-conductive. So when it leaks, it just evaporates. And we've chosen
Yes.
that when it evaporates, it, goes into the atmosphere, breaks down within 3 days and comes back as a TFA, a naturally occurring.
Yep.
So it's
Well,
not,
yep.
forever lost up there. So that's really the difference with our technology. And yeah, and we're hearing, and we have some papers that talk about NVIDIA, Intel, the great minds saying that, yes, this is two phase is better today, but it will be required for the future generations of chips.
Yeah, and so let's get that up because to me, two phase got a bad rap early on because the early pioneers in two phase were trying to do it in an immersion tank,
Yes.
right?
Uh-huh.
And it was a nightmare, right?
Yeah.
And so, right, so I mean, and let's the idea of immersion right now for GPUs, I pretty much it's a difficult approach to me, in my opinion, right? And so, but you guys, which were the first ones that I saw, were effectively using a two-phase approach, but to the direct chip makes
Mhm.
all the difference because there it works perfectly.
Yes.
And
Yeah.
it really puts you in rare air as to how you are doing it. Talk to me about how the adoption rate of that technology starting with a headwind, right? Where that, some people are
Yeah.
confused by there. How is it being adopted in the industry so far? How long have you been producing racks and getting them out into the things? Give us a sense of how well it's being adopted right now.
Yeah. So we launched our product for in April of last year, is when we began shipments. And so we've seen adoption from really the leading edge companies that are prioritizing kind of the AI data center. So you'll see in some of our announcements, the companies that we're working with, IM Data Centers, Nordic Data Centers, are building exclusively for AI customers. And so they're building today. A lot of them are companies that are just, you know, not starting out, but starting this business. I'm getting too specific in my mind, but they're investing in this today for far in the future. So they're looking at what are the technologies going to be then. We're also getting a lot of traction in Europe and now in APAC, where sustainability does actually matter. So the
Yep.
free cooling that we're enabling becomes very significant. There's one data center that we're working with in Singapore where the two-phase direct-to-chip, our inlet water temperature requirement is 31.7 degrees C. We usually operate at about 6 to 8 degrees C better than single phase. So that puts them right below where Singapore's average heat is.
Yeah.
So it's the difference of our technology enabling, it's like 97% of the year free cooling versus just the 6 degrees difference. Single phase was like 10% of the year when they did the
Yeah. Makes a
calculations.
big difference.
So yeah, so we're seeing good traction. Single phase has been in the market for a long time. We do find, I think what you were referencing at the beginning, there's a big education factor. And that's one of the kind of things that we work on in marketing is this kind of myth busting around some of the narrative that, and you're right, there was, when you hear two phase, people thought immersion, they thought big open tanks,
Yes.
third generation fluids that didn't have the properties that fourth generation does that enables it to break down and just in open to the air for every time it was serviceable versus ours is in a closed loop. So it really shouldn't be getting out.
Right.
Yeah.
Yeah, and I don't think that the average person, well, surely the average person, but that even most people who are in the knowledge or in the know in the data center don't know the horror stories of the early water directed chip and the early single phase directed chip being conductive, then that were the problems, right? But there's a reason why everybody's using metal fittings today rather than plastic fittings. There's a reason why today everybody's looking, right? People don't know the horror stories that were the first ones that came out. There's been a really fast learning curve in being
Yeah.
able to adopt to this. One of the advantages that you guys have that I enjoy that is the fact that I can get more of the cooling of the box. I still, most people do not realize what the ratio of direct chip versus all of the heat that can be gotten from the IT. Talk to me about how you handle the overall, heat profile of a box of GPUs and how much of it do you extract when you're working with a client? How much of the total kilowatts of the box are you able to extract?
Absolutely. So on average, and obviously, as you know, it depends on kind of the configurations, but it's about 85%. We can used our technology to remove additional heat from the memory.
Yep.
We've developed things for that, but it's about 85%, which then is handled by the air cooling that's already there.
There.
Yeah, so it's becomes a very manageable amount. There are
It's still a
situations.
mix. It's
Exactly.
still a
Yeah.
mix of that air cooling and there. What is the ratio that you guys are seeing of like on a rack deployment? What percentage are all the racks being deployed as the capability of being, and by the way, what is your upper limit density? Do you have one right now that you guys earmarked to say this is what we'll do on a per rack basis on a kilowatt rating?
Right now, it's funny. We surprise ourselves every day in terms of
Yeah.
performance. We just did testing this week where we had previously tested to 2200 watts per socket, and they just on a single loop tester in the lab behind me did 4500 watts per socket. So what our next product on the roadmap is a 250 kilowatt CDU solution, but in testing we're outperforming that number already. And we're introducing a new fluid with slightly that delivers a slightly higher performance too. So to answer your question, beyond 250 kilowatts per rack.
Per rack, beyond 250 kilowatts per rack. And that's the future generation, or that's the one that you have out right now delivered?
That's future generation. That'll be available in Q2 for POCs and Q3 for general availability.
So if I need one right now, is it 100 watts per rack, 100 kilowatts per rack?
Yes, that is what we're doing right
What
now.
you're doing right now. Yeah.
Yes, yeah.
And that's still, that's the vast majority of the loads. Um, that's great. What I wanted to ask now, it was one of the things that's interesting that's happening in the industry is, are you your go-to market? Um, a lot of your competitors are setting up agreements with the IT OEM manufacturers and shipping it with part of the kit, to use the European word, right? So if
Yeah.
I'm buying the server, they're actually buying the manifold, they're buying the in-rack CDU, they're buying the CDU on the floor as part of the deployment of selling it. And right, I don't want to disparage anybody, but as the guy who was working with both the end user and the facility manager, so let's say the data center operator plus the guy moving racks in there from one of the big IT OEMs that has got a whole bunch of kit, we're noticing that there is a real knowledge transfer problem
Oh,
between the
interesting.
amount of engineering that needs to be done from the CDU into the server, from the CDU back to the chiller. So in other words, the complete knowledge stack. And again, I'm going to do a shameless promotion as to one of the advantages to working with a company like us from your perspective and from a client perspective is I understand the needs mechanically from the chiller all the
Mm-hmm.
way through to the server requirement. And we're a design build company, so we make sure that we engineer the solution all the way through the stack. Are you predominantly selling off into the data center industry? Are you trying to market to the IT OEMs as being part of their stack? What is your go-to strategy of selling it into the market? Like if somebody wants to get in touch with you, are they buying it through Dell, or are they buying it directly from Accelsius or a channel partner? How do you go to market?
Great question. And I think to your point, I mean, that's how we met, is because we
Yes.
wanted to talk to you because we agree that there needs to be an expertise from the chiller to the chip for
Yeah.
sure. And so we want to be partnering with a company like yours to deliver that end-to-end solution, because that's definitely a barrier to liquid cooling adoption, is this lack of owner. Some of the companies we've worked with have mentioned with previous deployments, there's a lot of finger pointing when you get those situations that you're talking about where you've bought the liquid cooling through the server OEM. Who owns the replacement parts? Who owns the service? There's a lot of finger pointing, and so this particular customer had a year of just waiting for them to figure it out between the two of them.
Yeah.
We personally are 100% through the channel. We are partnering and talking with the server OEMs, of course, but we also are importantly working with the companies like yourself, with Unicom, with ECS, to do the integration, to have the expertise. And then we've also put together a warranty and a service program that ensures that our customers feel confident that Accelsius will continue to stand by our system as it's integrated into more and more things. We even offer the only liquid cooling company that offers a warranty on any consequential damage to the chips themselves as well. So your point is a very valid one, that it needs to be an ecosystem approach for
Yeah.
sure. And so we are working very hard to make sure that we can deliver that.
Good. So thanks for that. And with the last few minutes that we've got, about a few minutes left, I want to talk about the future of all of this. And so I want to start by saying, I am not bashful to ideas. I would say that when I started my companies in my 30s, I thought I knew what I was talking about, right? But now at 57 years old, I'm pretty sure I know where the industry is going at this point, having seen a couple evolutions of what the data center is. And I wish I could take credit for it. Again, this happened for lots of conversation with lots of people at the IT OEMs, but especially Paul Perez, who I referenced earlier. We were talking about the difference between modeling and inferencing. And I remember
Okay.
him telling me a story that he was talking to Michael Dell saying, look, large language model is only the first step of AI. The inferencing is going to be completely different. And it is my hypothesis or my position that we're going to see a paradigm shift in the data center as the
Mm-hmm.
need as more and more companies not just relying on the public information from which a large language model is built, but companies begin to deploy models on their own private data. Let's call that a small language model. I don't think
Okay.
we're seeing it quite yet, but we will. We are seeing companies that are trying to leverage the cloud, and why you guys are so busy, right? Trying to build out the hyperscale guys to allow the average business to do it as a service. But we're seeing more and more companies now want to put private AI models out, small, medium, and large, and train
Mm-hmm.
specifically there. When
Mm-hmm.
that is done, we're
Mm-hmm.
going to see inferencing. And it is my posture, my position that that is a different animal. I can train models regionally in wherever I could transport data to, but when we get to the rules of inferencing, they are going to have to be highly distributed, meaning they're
Mm-hmm.
going to have to be geographically diverse. I like
Right.
to say that they are going to go from the American pro football cities of the world, where we've run out of power, to the American high school football cities of the world. You have to pardon me, I was a football coach, right? To the high school football cities of the world, because that's where the IT device is going to demand it. So the IT device and the people are going to demand load, at a local federated level, and it's going to look just like the old telecommunication pops, right?
Mm-hmm.
You have
Yeah.
large central offices, but the pop were all in a local community. Do you have any opinion as to that idea that I'm having that we're about to see in the next 5 years, tops, a shift from not just modeling, but modeling plus inferencing? And how do you think that might impact the cooling industry?
Absolutely. And I think that shift, I mean, when you were talking about that, a lot of, as an analyst, questions I was asked is, when is edge computing going to take off? And it's like, I don't know. Like, I could see it on, industrial automation on factory
Yeah,
floors, like at, McDonald's, like point of sale, but there wasn't anything other than like self-driving cars, which is a part of inference, right? So yeah, I think that's going to change the model. I think I think it'll make it truly, truly, truly mission critical. So these
yeah,
edge locations, which maybe were previously, more important for like Netflix viewing or streaming, will be used for ensuring self-driving cars or making other like key, city, and I'm sure with your customers, smart city kind of applications,
yeah,
right? That's mission critical stuff. So ensuring that it's running effectively, that it's not being cooled by air where you can be throttling 60% of the time. So I think it will drive liquid cooling because you'll need to be getting the maximum performance from it. And then I do truly believe it'll be two phase will be the preferred solution because there's not that catastrophic damage situation. And one thing we didn't talk about with single phase, the other thing that's coming to light more as it's been deployed for longer is the maintenance required for single
yeah,
phase solutions. And it's frequent versus two phase, like there's no servicing requirements, there's no refill requirements for the
yeah.
fluid. It should last the lifetime of the system. So I think in edge deployments, you want as little maintenance as possible, and you want to make sure there's as little risk as possible. So I do think that that will drive interest in two phase direct to chip. You said something else about, I think the edge piece will be really interesting. It was prefab and modular. Those are
Yeah.
two trends or hot topics, and I'm thinking about your Gartner chart again, but that have been talked about for so long. And prefab modular kind of like power skids took off, but there wasn't
Yep.
like micro data centers that really took off. I think that will in
Yeah.
inferencing. I think that will
Yeah.
really,
Inferencing, you're going to see it. I agree with you.
Yeah.
With a few minutes, I love doing this. I'm going to give you four questions, kind of look at a little quick, a quick takes on industry development. So, four ones. What's the biggest myth about liquid cooling?
I think the leaks don't happen. I mean,
Yeah,
you said it, like there's, I don't know how many points of connection in a system that the fluid's going through. Like leaks will happen. So we need to talk honestly about it. And what do you do when a leak occurs? Have, good service, good coverage, but then also try to pick a fluid that doesn't destroy
great,
your
good answer. Give me one major bottleneck still holding back widespread adoption of direct-to-chip cooling and specifically two-phase. Let's talk about the Accelsius product. What's one big bottleneck that's holding back from widespread adoption?
I would say education and kind of comfort. You said it. I mean, this has been crazy fast how this adoption curve has happened. And so we look at, who's downloading our papers. 80% of it are just people educating themselves. They're
Yeah.
not imminently making a purchasing decision, which is fine, but there's a lot to learn about this in a very short time because people were kind of, surprised by this. So I think education and that will come with time.
So to that end, let's be the opposite side. Now, I think your technology is the breakthrough, but I'm going to ask the question: what's the most exciting breakthrough in data center cooling that we should be paying attention to? I'm going to set you up and say that I think the adoption of two-phase cooling is something that people still don't quite well understand. So to me, it's a breakthrough that's there. But do you have anything to add to that?
No, I really do. And I think, the one other kind of bottleneck a little bit is people in the procurement wants multiple options. They're not going to, Excelsius may have the best mousetrap, but procurement policies dictate you need other options, right? So there's two of us in the market now. There's another one coming to the market. So I think as more companies talk about it and it's clear that there's a wider supply chain,
Yeah.
partnering with a large contract manufacturer, which we'll be doing an announcement with soon, that it gives us that manufacturing scale as well. So I think
Yeah.
those things kind of on the procurement side will really drive comfort.
Great. So if you had one piece of advice for a data center operator that is considering adopting some liquid cooling in their data center, what would it be?
I think just think about the fluid. It's all about the liquid. Think about the fluid. Which
Yeah.
fluid would you rather have in your data center?
I think that's great. I appreciate it. I think this accomplished everything that I wanted to. Thanks, Liz, for your time. It's been wonderful getting to know you in the last, year and everything since we were introduced, like you said, and I know that we're going to be doing an appreciable amount of work. And so thanks for coming on today. And any last words that you want to do to pitch? How do we get in touch with Excelsius and anything just to close out?
Yeah, actually, you know what's funny? I will spell Excelsius, although it's on. So
We got it on your card there. So yeah,
perfect. Yeah,
it is a little tricky one, right? To go find it and whatnot. But yeah, so thank you. I really appreciate it. I know we're going to be doing a lot of work together. You guys are doing fine work in the industry. I love the technology. And so thanks for being a part of this today.
Yeah, thanks for the invitation for the chat. I enjoyed it.
All right, be well.
Thanks. Bye.